Okay, last part here. Now we're trying to figure out some numbers on these graphs, and starting with the peak force. And so the peak force is C and E, right? And there's two different shapes. You got to remember that the one that has the crumple zone, so when the sphere hits, it just barely smashes down like this. But when the cone hits, it's made with this long tip, and so this long tip makes it have a crumple zone, and so this thing will smash down considerably. And so where this one will have a small time, this one will have actually a larger time. And what that means is we're in both cases we're stopping the cart, and so a smaller time is going to give us a much greater force. And so this one will have a really big force and a small time, and this one will actually have the opposite. It will have a small force and a big time. And I hope you can see that the difference between these two graphs. One stops very abruptly, which is the purple one, and one stops over a longer period of time. And the longer the period of time that you can stop in, the safer the collision will be. And that's what a seatbelt and an airbag attempts to do. Is the seatbelt and the airbag attempts to decrease the force by increasing the time, right? You want a longer time, and so if you have a seatbelt, right, it's going to allow you to stop um, less abruptly. And if you have an airbag, I don't know, maybe I should put it in green instead of red because red looks so bad. If the airbag, it stops you even more softly. So we want it to have a longer amount of time. So the peak force actually is this top, and if you look straight across, you can read the graph and see what the peak force is. On this one, same thing. Peak force is something right in there. So this one has a smaller peak force, and so that is going to be the cone. And this one has a much greater peak force, and that is going to be the sphere. Okay, what else can we get out of this? The peak force is important, but we also want to get the average force so that we can show the equation, because the equation actually Ft equals impulse is not the peak force in the equation. It's the average force. It's the, in the way you write it, we put it a little like this, an average force over there. And so let me go to the other picture and show you the math of how we figure out the average force. Peak force is easy. Look at the graph. Let me go to the next picture. In this picture, we're going to show how to get the average force. And so what we have here is, first of all, we got to figure out the time. And the time is actually really pretty hard to figure out. And so in a test, I'm going to have a large variation of what I'll expect you to be able to do. If you're off by a little bit, it'll be acceptable. If you're off by a lot, it will be not acceptable. Okay, so how do we figure out time here? Well, the time here is not 1.4 seconds, and it's not 1.45 seconds, and it's not 1.5 seconds. That's the time from when I started the timer a long time ago. The time we're talking about, in this case, the T, is we're talking about just the time frame pretty much right in here for this one, going this way. And for the other one, it's the time frame something like this for this one. And this is obviously a larger time. It turns out to be about 0.8 seconds. And this is approximation, and this turns out to be about 0.3 seconds. And how do we know that? So what we're doing is we're taking 1.43, and the 1.43 in these numbers here, what it allows us to do is that 1.43 minus 1.40. So 1.43 is somewhere in here. And so what I've actually done is I've kind of averaged out the time that you see here and down here. So it's kind of an average time, which is why it's really difficult to get. But so on the quiz, you'll see that it's a multiple choice question. So that should narrow things down for you a little bit, right? And so this one is 1.43, which is basically, whenever we do these things, we always do TF minus TI or VF minus VI. And so we look at the final, which would be something like that, minus the initial. So this is T final minus T initial, and this is also, and actually technically it's a lowercase t. An uppercase t is something we'll study later. T final minus t initial. And so 1.5 is right there, 1.42 is over there, and so this length here turns out to be about this much time passing, which is a greater amount of time than this time here, which is about 0.03 seconds passing. Okay, that gives us the time frame. Now, what do we do? So the next thing we do is we're going to look at how we figure out the average force. And so this, you gotta remember, this little line over the top means average. That means average. And so the impulse is taken from the graph. The impulse is taken from the graph above. It's the area of the graph. And then the time is taken from the graph as well. Time is taken from the graph as well. And so what we're left with is we're left with the unknown, which is the impulse. Sorry, which is the average force. And then we divide each side by 0.3 on this side, and you get an average force of that. Now, does that make sense? So let's look at both of these. The average force of this one, if you do it, is around 6, and the average force of this one is around 16. So let's go back up and see if 6 and 16 as an average makes sense. So let me scroll back up. And so here we said that the peak was about right there. And so the average would be 16, somewhere in there. And it doesn't look like an average visually, and that's because look at all these dots. All the dots are very high. And so even though it doesn't look like the middle, average sometimes the middle, it actually is the average around 16. Same thing here. The average we said was around 6, which is about right there. And so anyways, mathematically, that's how you do it. So there's your math, and actually take a look-see at that and see what you can do. All right. Have fun. Where'd my mouse go? Can't find it. There it goes.